Alright folks, let's do number 42. Let's see what this is asking. Let me erase parts of this. There we are. An attacker at the base of a castle wall at 3.65 meters high. So I'm just going to mark the variables. So here's the here's the guy at that base, and this is the castle wall. And the castle wall is 3.65 meters. Throws a rock straight upward with the speed, so he throws a rock straight upward with the speed of 7.4, or in this case, I'm going to call it some initial velocity. And if you know your motion, folks, meters per second at a height of 100.5 meters above the ground. Okay, so this is going to be, so I guess I'll call this capital H, and I'll call this little h, which is 1.55 meters, and the initial velocity is 3.65 meters. And will the rock reach the top of the wall? I encourage you to pause this video and to give this problem a shot. Presuming you pause this video and give this problem a shot, let's solve this. Alright, let's solve this. Alright, so G is going to be 9.8 meters per second square, and I'm just putting the magnitude of the speed. So think about the motion, folks. You throw a bar rock at 1.55 meters above the ground. It's going to travel some initial velocity upward, so that means that initially the direction is going to go upward, but it's going to slow down because it has an acceleration downward towards the center of the earth, which is what we call gravity, at 9.8 meters per second square. It's going to slow down to the point where it's going to stop at some specific maximum height, and it's going to come back down. So it really depends on how much the initial velocity is. And the question is, will it go farther than 3.65 meters? That's what it's asking. So in other words, folks, the motion of this graph is going to be the t-axis, and this is going to be the y-axis. And you can already set up the motion here as y being some initial velocity t minus gt squared over 2. This is the actual physical motion depending on what time is. The output is the height that it reaches. And the maximum height that it reaches, it's when the final velocity is 0 and you have some initial velocity minus gt. So we've already solved this, and I believe the problem, the equation, when you put the gt, you have gt squared divided 2 over 2. That's minus that. Y of the max height, the equation that I set up for you guys, is going to be nothing more than gt squared over 2. This is literally going to be the equation for the maximum height. Once you solve for v naught, chug it in there, or actually, you have your new equation as y being the max being v naught squared over 2g. So notice that all we did is find the specific time where the final velocity being 0. So we found for that specific time, I'll call it t naught, I guess, or t naught, and then we find the time for this y naught. Y naught being this equation. So all we're going to do is we're going to plug and chug. We're going to put 7.40 meters per second square times 2 times 9.8 meters per second. Let me fix the units. There we are. So all we have to do is put 7.4, square that, divided by 2 times 9.8. And then their maximum height here is, I got 2.79. And I forgot to set something up, folks. I forgot to put the initial height in there, so let me add that. That's the distance that it travels, so let me add that to 1.55. So the actual maximum height is 4.34 meters, and actually the motion doesn't look like this. Let me fix the motion. So there you go, folks. The maximum height is going to be 4.34 meters. So just the actual motion equation that you're going to use is this. I'm just going to modify this a little bit. So it's going to be some initial height added to b naught square over 2g. So you just have to add that little with the extra h in there. So 1.55 plus v square over 2 times g. Let me double check that. 40. What the fuck? I got 45. What did I store? 29. Oh yeah, that's because I didn't store this. All right. So once you fix that, there you go. 4.354 meters. So that's part A. If so, what's its speed at the top? Okay. So I didn't. All I found is the position where you get the maximum height. I didn't find the actual position where the height reaches, but it does go beyond 3.65 meters if the maximum. So that means that somewhere in here, it's going to be the time it takes to find that. And all you have to do is chug in capital H and let this be your equation, b naught t minus gt squared over 2. And you minus the g on both sides, so you let 0, and so you'd be left with h minus capital H plus b naught t minus gt squared over 2. Use the, I guess you're going to have to use the quadratic formula for that. All right, folks, the time I found that it takes here would be 0.38 seconds, and then the other one is 1.13 seconds. I'm showing everything. I'm showing the whole work here, folks. So that's the time it takes for the height to reach 3.65 meters. So that means that the ball is going to travel upward, and it's going to come, and then if it bypasses, it's going to come back down. So if so, what is the speed at the top? Well, we just found the time it takes. So now all we have to do is plug in the other equation, which is going to be some initial velocity minus gt. So one is going to have the upward velocity, and the other one is going to have downwards. So I did store the time in there. So let's that's just going to be saying vt or v minus gt, and I have the downward velocity. What did I store here? Oh yeah. Let me store the other one too. Okay, well, okay, so at 1.13 seconds, the downward velocity is going to be, the velocity is going to be negative 3.69 seconds downwards. And then the other one, when it goes towards the top, is going to be 3. I'm so confused right now. What did I had here? Yeah, negative 3.69. Oh, it's the same thing. Okay. I didn't know it would be the same thing though. All right, so 3.69 meters per second. So one of them is going to be upward, and the other one is going to be downward. Find the change of speed in the rock thrown straight downward from the top of the wall with the initial velocity at 7.4 meters per second. So that's going to be a new motion graph. So find the change of speed of a rock thrown straight downward from the top of, well, I think the change of speed is just going to be this, I guess. Find the change of speed, the change in speed of a rock thrown straight downward from the top of the wall with the initial velocity, and then moving between the same 2 points. I'm not sure what they're asking for, to be honest, but if it's asking for the average change of speed, I'm going to just pull up the answers. See what it says. All right, folks, this is going to be the solution manual for you guys. I'm just going to pull that up. Actually, I guess when they were actually for the change of speed, they were actually talking about the change of speed. Oh my God. Okay. So initially the ball is thrown at 7.4 meters per second, and apparently they find the downward speed. They use whatever equation they have to find the final speed at this at between these 2 points, which is 95. Wait, what? Yeah, that negative 9.79 meters per second. So they take the magnitude to find the change of speed. At this, so this is the change of speed for part A, part B, and it's the same by assuming the rock passes the top of the wall and find the speed there. If the speed comes out imaginary, the rock will not reach the elevation. The rock does reach the top with a speed of 3.69 meters per second. And we find that the change of speed is going to be 2.39 meters between those 2 points. And the magnitude, and what is part D? Does the change of speed downward move in the rock agree with the magnitude of the speed of the rock moving upward? Of the change of speed rock throwing upward is going to be this, and it does not agree with 2.39 meters per second. All right, folks. I just don't want to keep interpreting these problems or keep setting up the motion graphs. But there's a solution manual for you guys. All right. Goodbye.